You may or may not remember that we had started lesson 4 a few weeks ago, the real zeros of polynomial functions, and we had gone over the rational zeros theorem, or it's also called the real zeros theorem. Here we have our function 2x to the 4th plus x cubed minus 19x squared minus 9x plus 9. And if you look back at your notes, we have to make two lists, a list for P and a list for Q. The list for P are all possible factors for the constant term of our function. The list for Q are all possible factors of the leading coefficient of our function. Our constant term is 9. We can have positive or negative 1 times positive or negative 9, because we can have positive 1 and positive 9, or we could have negative 1 times negative 9. So we always want the plus or minus in front. Let's see. Then we could have 3 times 3, and I think that's it for 9. 2, that's nice, it's a prime number. The only factors will be 1 and itself. Now, the next step after you make your list for your P and your Q, step 2 is P over Q. This is where you create another list of all possible combinations of your list from P over your list from Q. I like to start with the first number in P and put it over each number in Q. I start with plus or minus 1 over 1, which is 1, and then plus or minus 1 over 2, or 1/2. Then I go on to the next item in P. Plus or minus 9 over 1 is 9. Plus or minus 9 over 2 is 9/2. And lastly, the 3, plus or minus 3 over 1 will be plus or minus 3. Plus or minus 3 over 2 will be plus or minus 3/2. This is the rational zeros theorem, is ultimately creating this list of P over Q. On this list will be the rational or the real zeros of this polynomial function. It's not all of the zeros. You could have zeros that are irrational. Say, for example, the square root of 2 could be a zero of this function. Because it is irrational, it will not be on this list. But this list gets us started on the way to finding the zeros of a polynomial function. That is what we use this theorem for. In the following videos, you will see how we use this theorem to help us find all of the zeros of a polynomial function.